Okay, what did we discuss in the last class? We discussed about Riemann's condition, and based on Riemann's condition, we discussed one theorem also. In the theorem, we saw that the conditions, if is integrable, if satisfies Riemann's condition, and lower integral is equal to the upper integral. These three conditions are equivalent. We have proved that. Now, next we are going to see comparison theorems. Okay, in this section, we are going to see, here also we assume that our function alpha, that is our integrator alpha, is a monotonically increasing function. Okay, and suppose if f of x is less than or equal, we are having two functions, f and g, on closed interval a, b. And f and g are related like this. That is, f of x is less than or equal to g of x for all x in our closed interval ab. Now, can we say that the corresponding integrals also have the same relationship? And we can actually, this is true. That is, integral, if f of x is less than or equal to g of x, then the corresponding integrals, integral f d alpha is also less than or equal to integral g d alpha. This is the first theorem in under the section comparison theorems. Okay, we are having 4 theorems here, and this is the first one. Let us see the proof and the formal statement of the theorem and the proof. Look at the statement. Assume that alpha increases monotonically on closed interval a comma b if f belongs to R of alpha and g belongs to R of alpha on closed interval a comma b, and if f of x is less than or equal to g of x for all x in closed interval a b, then we have integral a to b f of x d alpha of x is less than or equal to integral a to b g of x d alpha of x. So what is given to us? So our function, our integrator alpha is a monotonically increasing function, and we are given with 2 functions f and g. The functions both f and g are integrable, and f of x is less than or equal to g of x for all x in the closed interval a comma b. Then we can prove that the corresponding integrals, integral a to b f d alpha is also less than or equal to integral a to b g d alpha. Okay, this is the statement, and this theorem is an important 5-mark question. Let us see the proof. Okay, so what is given to us? F of x is less than or equal to g of x. So if you take a partition, then partition means what? Our partition will break our closed interval AB into small subintervals, and in each interval we can compare the values of f of x and g of x, because f of x is less than or equal to g of x for all x in the closed interval a comma b. Okay, therefore in each subinterval also we can write f of tk is less than or equal to g of tk. Tk is an element, tk is an element from the kth subinterval, and this is true for any subinterval. Okay, so for every partition, and this is true for any partition. So for every partition P, we have f of tk is less than or equal to g of tk, where tk belongs to the kth subinterval. And we are given with the fact that alpha is a monotonically increasing function. Okay, therefore, we can write delta alpha k is greater than or equal to 0. So delta alpha k means what? We know what is delta alpha k? It is alpha of xk minus alpha of xk minus 1. Okay, since alpha is a monotonically increasing function, alpha of xk will be greater than or equal to alpha of xk minus 1. Therefore, the difference between them will be definitely greater than or equal to 0. So we can write delta alpha k is greater than or equal to 0. Since this is a non-negative one, we can multiply the previous inequality by delta alpha k on both the sides. And this won't alter the inequality because this is non-negative. இது ஆல்ரெடி நம்ம கிளாஸ்ல இதை பத்தி நான் ஆல்ரெடி முன்னாடி ஒரு தியரமோட ப்ரூஃப்லையும் பார்த்தோம். ஒரு நான் நெகட்டிவ் குவான்டிட்டி எடுத்துட்டு மல்டிப்ளை பண்ணும்போது இன்இக்வாலிட்டி நமக்கு சேஞ்ச் ஆகாது. So this will imply f of tk into delta alpha k is less than or equal to g of tk into delta alpha k. Tk is from the kth subinterval. And this is true for any subinterval that is from k is equal to 1 to n. Therefore, we sum this inequality from k equal to 1 to n. Okay, so we can write this like f of t1 into delta alpha 1 is less than or equal to g of t1 into delta alpha 1, etc. up to f of tn into delta alpha n is less than or equal to g of tn into delta alpha n. Now sum vertically all these terms in the left hand side and right hand side. So what will we get? Sigma k equal to 1 to n f of tk into delta alpha k is less than or equal to sigma k equal to 1 to n g of tk into delta alpha k. And what is this actually? What is this sum? This is what?
Riemann-Stieltjes sum.
Yes, very good. So this is Riemann-Stieltjes sum. So this is nothing but s of p f comma alpha. Here we are having f of tk, and instead of f of tk, this side we are having g of tk. So this is Riemann-Stieltjes sum of the function g with respect to alpha. So this is s of p g comma alpha. So we are having the inequality that sp f alpha is less than or equal to sp g alpha, and take this as equation, and of course inequality, and mark it as 1. Now we are given that the functions both f and g are integrable. So given that f comma g belongs to R of alpha. Now function integrable means what? Apply the definition of Riemann-Stieltjes integrable function. So we can write this therefore by the definition of Riemann-Stieltjes integrable function, we have for every epsilon greater than 0, there exists a partition p epsilon such that for every partition p finer than p epsilon, modulus sp f alpha minus integral a to b f d alpha is less than epsilon. Okay, and we know that modulus of the difference between these two is less than epsilon means what? We can write this as integral a to b f d alpha minus epsilon is less than SPF alpha is less than integral a to b f d alpha plus epsilon. Okay, so the difference between these two is less than epsilon. That means what? SPF alpha lies in between integral a to b f d alpha minus epsilon and integral a to b f d alpha plus epsilon. Okay, so we can write this inequality like this. Now, since g is also integrable function, by the similar argument, we can write integral a to b g d alpha minus epsilon is less than integral sp g alpha is less than integral a to b g d alpha plus epsilon. Actually here, I am missing a portion because you can understand that easily. Because both f and g are integrable functions means if the function f belongs to R of alpha means what? F is integrable. Then Applying the definition of Riemann-Stieltjes integrable function, given epsilon greater than 0, there exists a partition P epsilon such that for every partition P finer than P epsilon, this one, that is modulus of SP f alpha minus integral A to B if D alpha is less than epsilon. Now, G belongs to R of alpha means G is also integrable function. So, take the same epsilon, but you need not have the same partition. இதே partition P epsilon G க்கும் வரணும்னு அவசியம் கிடையாது. Okay. So actually அப்ப நம்ம என்ன எழுதிக்கணும்? P epsilon dash such that for every partition P dash finer than P epsilon dash we will have SP G alpha minus integral A to B G D alpha is less than epsilon. அப்படின்னு எழுதிட்டு அடுத்த ஸ்டெப்ல என்ன பண்ணணும்? So அப்ப partition. So F க்கு வந்து P epsilon dash P dash னு வச்சுக்கோங்க. G க்கு P epsilon double dash P double dash னு வச்சுட்டு then next step என்ன பண்ணலாம்? Take P is equal to P dash union P double dash எடுத்தோம் அப்படின்னா then we can write the inequality 2 and 3. Actually இந்த மாதிரி இந்த டீடைலா எழுதணும், பட் உனக்கு இது புரியும் with understanding. ஏற்கனவே இந்த மாதிரி நிறைய தடவை பார்த்துட்டோம். ரெண்டு இன்டெகிரபிள் ஃபங்க்ஷன் இருந்துச்சுன்னா அது ரெண்டையும் கம்பைன் பண்றதுக்கு நம்ம என்ன பண்ணுவோம்? இதோட பார்ட்டிஷன் வேற அதோட பார்ட்டிஷன் வேற அப்படின்னு எடுத்துட்டு அதுக்கப்புறம் என்ன பண்ணுவோம்? ரெண்டு பார்ட்டிஷனோட யூனியன் எடுத்துட்டு அந்த யூனியனை வச்சுட்டு நம்ம அந்த இன்இக்வாலிட்டி எழுதுவோம். ஓகே, ஸோ த அண்டர்ஸ்டாண்டிங் நான் இங்க வந்து ஸ்ட்ரைட்டாவே எழுதியிருக்கேன். புரியுதாப்பா என்ன சொல்றேன்னு?
புரியுது மேம்.
ஓகே, ஸோ நம்ம ஈச் அண்ட் எவ்ரி லைன் ஒவ்வொரு தடவை பண்ணும்பொழுது நம்ம டெஃபினேஷன் கரெக்ட் தானா, அதுல கரெக்டா அப்படியே ஃபாலோ பண்ணி போயிட்டு இருக்கோமா அப்படிங்கறத நாமளே வந்து ஒரு தடவை செக் பண்ணிக்கலாம். ஓகே, so now we are going to combine the inequalities 1, 2 and 3. Okay, so 1 ல நம்ம என்ன வச்சிருந்தோம்? என்ன சொன்னோம்? S alpha is less than or equal to SP G alpha வச்சிருந்தோம். Okay, now from 2 ஓட left hand side ல என்ன இருந்துச்சு? integral A to B f d alpha minus epsilon is less than SP f alpha. Now from inequality 1 we can write this is less than or equal to SP G alpha. Now from 3 we can write this is less than integral A to B G D alpha plus epsilon. Okay, now so therefore what is in the left hand side? Integral A to B f d alpha minus epsilon is less than or equal to integral A to B G D alpha plus epsilon. Now you bring this minus epsilon to this side. So what will we get? Integral A to B if d alpha is less than or equal to integral A to B G D alpha plus 2 epsilon. And this is true for every epsilon. Okay, therefore the inequality must be true. That is integral A to B if d alpha must be less than or equal to integral A to B G D alpha. Okay. And the proof is over. You understand? And you have any doubt?
புரியுது.
Okay.
எப்சிலாங்கிறது ஆர்பிட்ரிங்கிறதுனால நம்ம அது இருந்தாலும் அது வந்து லெஸ் தென் ஆர் ஈக்குவல் டு தான் இருக்கும் அப்படின்னு சொல்லணுமா?
Yes, this is true for every epsilon means. So epsilon அப்படிங்கிறது என்னது? It is a very small quantity. It may be very very small one. For example, epsilon may be 0.1. Epsilon may be 0.0005. It may be any number. For any epsilon also this inequality holds means what? Originally the inequality is there with or without epsilon. Okay, because epsilon is very small quantity. And hence we can write like this. Okay.
Okay, ma. Okay.
Particular epsilon க்கு தான் true அப்படினா நம்மளால இத வந்து இந்த inequality இப்படி கன்வர்ட் பண்ண முடியாது. But if this is true for any epsilon, okay, that's why we have mentioned here. This holds for every epsilon. Epsilon நம்ம எங்க இருந்து எடுத்தோம்? Riemann-Stieltjes integrable function ஓட definitionல இருந்து எடுத்தோம். அங்கவே சொல்லும்போது நம்ம என்னன்னு சொல்லிருப்போம்? For every epsilon அப்படினா நம்ம ஆரம்பிச்சிருப்போம். Okay. So epsilon எப்படி எடுத்தாலும் நமக்கு இது true. Therefore this inequality holds for every epsilon and hence the inequality itself it is true.